Uh, Welcome. First of all, I want to start by greeting you guys. I know you are going to enjoy this lesson. My name is Teacher Jacob, and I'm glad for joining us. I want to talk about energy transformation. So, welcome to the exciting world of energy transformation. As we discussed, energy is the ability to do work. Okay? And it's constantly at play around us. So energy is constantly at play around us. Incredible thing about energy is that it's never created or destroyed. Energy is never created or destroyed. It can only be changed or transformed to another form of energy. So it simply changes from one form to another. So this fundamental principle is known as the law of conservation of energy. Today, we'll explore different forms of energy and see how they transform. So first thing you have learned is that energy cannot be destroyed. It can only be transformed from one to another. Now, let's talk about light energy. Light energy is also known as radiant energy or electromagnetic energy. Electromagnetic energy or radiant energy. So it's a form of energy that travels in waves. You know a wave? It is the only form of electromagnetic energy or electromagnetic radiation that is visible to the human eye. This we can see light energy, and it travels fast. You see, light energy travels incredibly fast. The speed of light is the fastest speed known in the universe. Hope you know that. Now, example one of the light energy that we normally it is normally there that we can see is the sun. So the sun is our primary natural source of light energy. Inside the sun, we have nuclear energy is released through a process called nuclear fusion. This nuclear energy is then converted into radiant energy, which travels through the space to Earth as sunlight. You see that? So this sunlight provides both light and heat. The light provides both the light and the heat, making life on our planet possible. So nuclear energy transformed into what? A radiant energy. A radiant energy. Now, example two, we also have a bulb. The bulb we normally use in our homes, in our houses. Now, when you switch on a traditional incandescent light bulb, electrical energy flows through a thin filament. The filament is normally inside the bulb, right? Filament. The filament resists the flow of electricity, causing it to heat up intensely, transforming electrical energy into thermal what? Into thermal energy. When it gets hot enough, it glows, converting a portion of the thermal energy into visible light energy. So modern LED bulbs are such more efficient, converting electrical energy directly into light energy with every little heat waste. Another example of energy. Now we are done with the light energy. We have explained about the sun, and we have also explained about the bulb that we normally use in our houses. So that will help you to understand the light energy. That is one of the energy that we can see with our eyes. You see that? Now, sound energy. Sound energy is the energy produced by vibrations. Sound energy is normally energy that is produced by what? Vibrations. Now, when an object vibrates, it creates disturbances that travel through a medium. When a sound vibrates, it travels through a medium. And the other time when you were in this, when you were in school, you talk about sound travel based in solid and less in vacuum. So we have examples of the medium of sound. So we have like air, water, and also solids in the form of waves. That's how sound travels. These waves carry the sound energy. These waves carry the sound energy. Like I can clap like that, you can hear the sound is being produced. So sound is produced as a result of vibrations. So when you pluck a guitar string, the string vibrates rapidly. This mechanical energy of the vibration string causes the surrounding air molecules to vibrate, creating sound waves that travel to your ears. Your ears then convert these vibrations back into signals that your brain interprets as music. So, the mechanical energy of the vibrating string transforms into sound energy. I hope you get that. Now let us give an example of a ring bell. Normally used in your at your workshop or sometimes in this institution like schools. Now when you strike a bell, the bell itself vibrates. So this vibration generates sound waves that spread into the air. The initial mechanical energy from striking the bell is converted into the kinetic energy of the bell's vibration, which then produces sound energy that you hear. Another example of energy, we are talking about heat energy, the heat energy. The heat energy or thermal energy is also called heat energy or thermal energy. So is the energy associated with the random motion of atoms and molecules within a substance. The hotter an object is, the faster its particles are moving and vibration, meaning it has more thermal energy. So examples of heat energy, we can talk about the boiling water or a stove. In explanation, I can say that when you place a pot of water on a hot stove, the stove transforms thermal energy to the pot. You see that? This thermal energy causes the water molecules to move faster and faster, increasing the water's internal energy and temperatures until it boils. If it is a gas stove, the chemical energy is the gas is converted to thermal energy. See that? If it is an electric stove, electric energy is converted to thermal energy. So another example, I can talk about rubbing your hands together. So when you rub your hands together like this, when you rub your hands together vigorously, you are doing work which involves mechanical energy. The friction between your hands causes the molecules on the surface to move more rapidly, increasing the thermal energy. This is why your hands feel warm after rubbing them together. Mechanical energy is transformed into thermal energy. So in that context, you can see now that the mechanical energy is being transformed into thermal energy or heat energy. The last one, the second last, we're going to talk about electrical energy. Most of us, we have heard the word electrical. And sometimes we think the electrical energy are those wires we see there, the cable that we see. Now, electrical energy is the energy carried by moving electric charges. Is the energy carried by moving electric charges. So typically electrons. It is one of the most versatile forms of energy because it can be easily transformed over long distances and efficiently converted into other forms. Example is lightning. We all know lightning. In a thunderstorm, Friction between ice particles and water droplets in the clouds causes a buildup of static electric charges, creating immense electrical potential energy. The electrical potential energy. When this potential difference becomes too great, it's released. It is released as a sudden, powerful discharge, lightning. That is like that powerful discharge is lightning. You see, this transforms the electrical energy into intense light energy, the flash. Sound energy, we also have the thunder, and also the last one you have the significant thermal energy hitting the air. I repeat, when this potential difference becomes too great, it is released as a sudden, powerful discharge, lightning. This transforms the electrical energy into light energy, sound energy, and thermal energy. So the light energy is the flash, the sound energy there is the thunder, and the thermal energy is there, the heating the air. You see that? Another example is powering a fan. The fan that normally when you feel hot in your house, you can use what you call the fan to generate or to bring about to lower the temperature in that room. Now, when you plug in and turn on an electric fan, electrical energy flows from the wall outlet to the fan's motor. Inside the motor, the electrical energy is converted into mechanical energy, causing the fan blades to rotate and move air. Some of the energy is also lost as thermal energy and sound energy. So when the motor gets slightly warm, that is thermal energy that is being lost there. And when the wiring noise that you hear, that is a sound energy. Another example of energy that I want to talk about is chemical energy. Now, is energy stored within the bonds of atoms and molecules? Now, this energy is released or absorbed during chemical reactions when these bonds are broken and new ones are formed. I hope you get me. That chemical energy is energy stored within the bonds of atoms and molecules. This energy is released or absorbed during chemical reactions when these bonds are broken and new ones are formed. Example of this chemical energy, we have the food digestion. The food we eat, like an apple, contains a stored chemical energy in its carbohydrates, fats, and proteins. When our bodies digest food, complex chemical reactions occur, breaking these bonds and releasing the chemical energy. This released energy is then used for various life processes, such as movement, maintaining the body temperature, and even nerve impulses. So the movement in itself is now that chemical energy. The chemical energy is the movement, and the thermal energy is the body temperature that you gain when the food is finally broken, after the peristalsis. Now the food undergoes digestion, and then we have the electrical energy, which is the nerve impulses. So when you eat food, you sustain life. If you go hungry for like 3 months, okay, of course nobody can stay hungry for 2 months or 3 months unless it's a miracle, but you can't. So you need food to survive. Another one is a battery. Now a battery stores chemical energy in its components. When Connected to a circuit, a chemical reaction occurs within the battery, causing electrons to flow. This flow of electrons is electrical energy, so which can then power devices like flashlight or a remote control. So chemical energy is transformed into electrical energy. The last form of energy is what we call the mechanical energy. Is the total energy an object possesses due to its motion, position, or configuration. So when I talk about the motion here, I'm talking about the kinetic energy. And when I talk about the position, I'm talking about the potential energy. So mechanical energy is divided into two, the kinetic energy and also the potential energy. So it is often the most visible form of energy. So example of this chemical where we experience mechanical energy is in the swinging pendulum. So at the highest point of its swing, a pendulum momentarily stops. Highest point, when it's swinging like this, you see at its highest point, it seemingly stops, having maximum gravitational potential energy. Maximum gravitational potential energy and zero kinetic energy. Kinetic is a motion. So when that motion stops, or when that motion loses its ability to push that swinging pendulum more further, that's when I'm talking about the gravitational potential energy. As it swings downwards, its potential energy is converted now into kinetic energy, reaching maximum speed at the bottom. As it swings upwards again, the kinetic energy is converted back into potential energy. This is a continuous transformation between potential and kinetic mechanical energy. The last example under mechanical energy is a diving board. When a diver stands at the end of the diving board, the board is bent, of course, that's natural, storing elastic potential energy, a form of mechanical potential energy. So now as the diver jumps, the board springs back, converting its electric potential energy into the diver's kinetic energy as they launch into the air. So as the diver rises, the kinetic energy converts into gravitational potential energy and then back into the kinetic energy as they fall into the water energy. Now, beloved people, that is the end of the lesson today. Now, understanding these forms of energy and how they transform is crucial to comprehending many natural phenomena and the technology that power our world. I beg to end there. My name is Teacher Naibe. I will be back.